In this tutorial, I want to explain the basic concepts of board diagrams in Flowerino. I have an Arduino board right here with two wires which simulate a push button when I short circuit them. You can see over here an LED which is linked to the pin number 13. So I want to achieve the following behavior. When I push the button, I want the LED to turn on and off. So let's see how we can do this. I create a new project. The name is mandatory, but the title and subtitle are optional. I go to the diagram editor. This mind map diagram is the main diagram of our model. I click on the board node and I hold Control and do a drag. What I'm doing right here, I'm adding a petal. The petal is the core concept of flower platform. Actually, the name comes from a flower which has petals. A petal is a component which knows how to do some interesting things at runtime. For my input, I need to set some properties. The pin, which I configure for pin number 3, and I would also like to change this property, internal pull-up. What does it do? Well, do you notice this icon? This brings up the petal documentation, or in short, petal doc of each petal. We can scroll down and we find the internal pull-up property with a detailed explanation. Actually, I need to have it to true because I don't use a resistor for my button. Now I will add another petal, an output petal. Pin is pin number 13, the one which has the embedded LED attached to it, and we notice something new. We notice the operations. An operation or a function is something that the petal knows how to do at runtime when somebody invokes it. For example, the toggle high-low operation switches the state of the corresponding output. Another concept is the event. If I right-click on the input petal, I can add a new event. At runtime, an event is triggered when something happens. For example, when a button is pushed, or a timer expires, an HTTP command arrives, etc. And the next step is to link this event to a target operation with a relation that's called an invocation. An invocation invokes the target operation when the source event is triggered, when it happens. In my case, when the value of input 1 will change, we will call toggle high-low operation. An operation can have be simple, for example this one, which always invokes the target method, the target operation, or it can have associated logic to it. For example, this one extracts the value from the value changed argument of the event, and based on this it decides if it invokes the target operation or not. In my case, I choose this one because for an input without a resistor, when it's pushed, the state is low. And now let's generate and run the code. There are several steps over here. The first step would be to download the project zip file. I take it and save it somewhere on the disk. I go there, I unzip it. We need to be careful to remove the trailing name. And now I double click the file. The second step that I need to do is to download a library. Actually, petals are often linked with runtime libraries that need to be downloaded only once. For example, if I download this library now for my next project, I won't have to do this again. That's why the name of this paragraph is verify and or add the libraries. So if you know that you have already downloaded the library, it's not needed to download it again. Anyway, if you don't have the library, the compiler would complain. So how do we include this? Well, this is easy. I choose the zip file right here, and then I verify that it has been included. So now I can compile and load the project. Let's see the result. So when I push the button, the LED turns on and off. And now let's add one more petal. In order to make the LED blink, I will add the timer petal. Delay, I put 1000. And I set it to auto start. Again, if we want an explanation of these properties, the petal lock is right here. I right click on the petal. We see that now there are two events. I choose the first one and I link with an invocation. The meaning is that when the on timer event will happen, which happens actually every second, it will invoke the toggle high-low operation. Let's do another generation. We can notice that the dialog looks a little bit different. For the first iteration we had this version, and for the second iteration we have this one. It's like that because if we take a look at this folder, we see that there's a file tutorial1.ino. This file is generated every time. The other one, customcode.h, is here in order to keep custom modifications. So in this, if we add custom code, it will not be overwritten by the generated code which resides here. So I click here. This dialog actually tells me that it's interesting to have the browser ask the location every time, like in my case. Because if I do this, the browser will save, will remember the last location. So for example, if I do another iteration, I go here again. Actually, I don't want to see this anymore. And you see the browser already remembered. So let's say I can iterate relatively quickly. Another thing that I want to mention is the fact that in my preferences I have checked this setting, use external editor. That's why the background of my Arduino IDE is gray, and when I when I compile, the IDE will check the file system to see if a new version of the file exists. Otherwise, I would have needed to restart the IDE. And here is the result. As you see, the LED is blinking, and the switch also works. So you see, if I click, it also works, but the timer automatically turns the LED on and off as well. And now it's your turn to play a little bit with Flavorino. For example, you can add another LED, or you can add some buttons that control the timer. For example, one button to start and one button to stop it. Let's do a short recap. We have learned about petals, the foundation bricks of Flower platform, and Flavorino. A petal can have operations. An operation is something that the petal can do at runtime. A petal can also have events. Events are triggered at runtime when something happens. And finally, invocations, which link events with operations. More precisely, when an event is fired at runtime, the target operation is called. And we need to keep in mind that some invocation may have additional logic. For example, this one always invokes the target operation. The other one invokes it only if a certain condition is met. We may have operations that are more complex as well. Thank you.